Okay, well, Noel is now occupied, so let's do some more examples. So our domain is going to change because we're now using vertical asymptotes, which is going to change our x values that we can use. So for this one, the smallest x value that we're going to use is 0 because we're never going to cross the x-axis. So our domain starts at 0 and continues on to positive infinity. Okay. And now our range, because we're going all the way to negative y and all the way up to positive y, is now negative infinity to positive infinity. Okay. And because they're inverses, we're going to change the way we do our end behavior. Okay, so now instead of starting with the x description and figuring out the y description, we're starting with the y and determining what x is doing. So as our graph approaches positive infinity, so as our graph goes up towards positive infinity, what are the x's doing? So now as we go up this way, we're going to the right, which means we're going towards positive infinity on the x. And now as our graph goes towards negative infinity, which means we're looking at our graph going this direction, x is approaching 0 because it's never going to cross this line. So we have 0 there now. All right? And our x-intercept, so we need the point where our graph crosses the x-axis. So you can get it from two places. You can look on our graph, which is right here, or you can look in this table. Wherever there's a 0 in this column, this point is our x-intercept. So our x-intercept is 1, 0. All right? And then our asymptote, we already said they're now vertical, so it's going to be x equals a number. Right? And because we're never going to cross the y-axis, it's x equals 0. All right? All right. For time's sake, we're just going to skip that one for now. You can go to the slides and look at that, but it's exactly like this one, just with 1/3 instead of 2. All right, so now we're going to get into where they have transformations. Okay, so these ones, we're going to have 3 t-charts, so make sure you have enough room that you can write all of those in. All right, so for this one, since it's log base 4 of x minus 1, we're going to use 4 to the x power first, okay, and make our chart that way. So we have x and f of x. All right, so we have -2, -1, 0, 1, and 2. So 4 squared is 16. 4 to the first power is 4. 4 to the 0 power is 1. And then 1/4 and 1/16. All right, so that's our exponential one. Now we have to do the inverse so that it becomes a log function. So go ahead and flip everything around. All right, so now that we have the exponential function, we flipped it to log base 4 of x here. Now we have to deal with this -1. So since it's x minus 1 in parentheses, when we put it into our table, it's going to change signs. But it's not going to go with the x's. It's describing what is happening to the left column. So in our left column, everything is going to go to the right 1. So we're going to make this f of x plus 1. And we have nothing that changes the new right column. So we're just going to leave that as x. So now we have 1/16 plus 1, which makes this 1 and 1/16. And then 1/4 plus 1. So we have 1 and 1/4. 1 plus 1 is 2. 4 plus 1 is 5. And 16 plus 1 is 17. And then these 5 values just stay -2, -1, 0, 1, and 2. All right. So we can graph those points. So 1 and 1/16 is just a little past 1. 1 and 1/4. 2, 0, 5, 1. And then we don't have room to graph 17, 2, so it's going to be out here somewhere. All right. So now we have to talk about what our asymptote is. So because this is x minus 1, and we shifted everything to the right one, our new asymptote is 1, so we're never going to cross 1 on the x-axis. So our graph is going to look something like this. And there we go. Now our domain, because we shifted all of the x values to the right 1, our lowest x value we can have is 1. So our domain changes from 1 to positive infinity. And our range doesn't change. It's still negative infinity to positive infinity. All right, now our end behavior. So as our graph approaches positive infinity, x is approaching what? So as our graph goes this way, we're going further to the right on the x-axis. So this is approaching infinity. And as we approach negative infinity with our graph, so as our graph goes down, we're approaching 1. So x approaches 1, f of x approaches negative infinity. All right, so our x-intercept this time is here. So it's that point, or you can go to your table and find the 0 in the right column. And our point is 2, 0. And now, because our lowest domain, or the line that we never cross, is 1, our asymptote is x equals 1. All right, so that's number 3. For number 4, we have f of x equals log base 3 of x minus 2. All right, so let's just start by changing this in 3 to the x power. So we can make our t-chart that way. And at this point, I think we've done this enough that I can fill this in without explaining too much. Don't forget the negatives are reciprocals, not negative numbers. Okay, so there is our t-chart for our exponential function. Now to get log base 3 of x, we're going to flip them around. So f of x goes in the left column, and x goes in the right column. So just rewrite everything in just their new columns. All right, so now for our third t-chart, because the minus 2 is no longer in the parentheses, that means this one affects how it moves up or down, which means it's going to change the right column of our table. So f of x, they don't change this time, so it's f of x, and then now, because it's moving up or down, we don't change the sign, so we have x minus 2. So keep all of your f of x values the same, so 1/9, 1/3, 1, 3, and 9. And now we're going to take these values and subtract 2. So negative 2 minus 2, negative 4. Negative 1 minus 2 is negative 3. 0 minus 2 is negative 2. 1 minus 2 is negative 1. And 2 minus 2 is 0. So now these are 5 points that are shifting our graph down. All right. So you can go ahead and graph those. So 1/9 is at negative 4, 1/3 is at negative 3, 1 is at negative 2, 3 is at negative 1, and 9 is at 0. All right. So because we didn't change or shift our f of x's anywhere, our asymptote is still 0. So we want to make sure it doesn't cross 0. And these ones are a little bit harder to draw because you're going down super close. All right, so now our domain, since we said we're never crossing 0, our domain is 0 to infinity, and our range this time is always going to be negative infinity to positive infinity. All right, so we have f of x approaches positive infinity. So as we go up this way, x is approaching, still going to the right, so it's still positive infinity. And as f of x approaches negative infinity, so as our pink line goes down, x is approaching or getting closer to 0. So the 0 goes there. Now our x-intercept this time is clear over here. Okay, so it's that point, which if you look in our table is there, is 9, 0. So 9, 0 goes there. And our asymptote, so our vertical line we're never going to cross, is this one. So we have x equals 0. Alright, so number 5, we have log base 1/2 of x plus 9 plus 4. Alright, so let's just start with our exponential function and do 1/2 to the x power. Alright, so we have x and f of x. We have our 5 values. So 1/2 squared is 1/4. 1/2 to the first power is 1/2. 1/2 to the 0 power is 1. And then we do the reciprocals, so we have 2 and then 4. Alright, then go ahead and do the inverse. So just flip-flop their places. Alright, so now, if you look at our equation, we have something inside the parentheses and a movement outside. So we're going to have 2 movements in our next t-charts. So our plus 9 changes left or right, so it's going to change this column, and it does the opposite. So it becomes f of x minus 9. And then the plus 4 changes our right column. So those ones are moving 4 up, so we keep it x plus 4. So 4 minus 9 is negative 5. 2 minus 9 is negative 7. 1 minus 9 is negative 8. And 1/2 minus 9 is negative 8.5. 1/4 minus 9 is negative 8 3/4. All right, and then we have negative 2 plus 4. So we have 2. Negative 1 plus 4 is 3. 0 plus 4 is 4. 1 plus 4 is 5. And 2 plus 4 is 6. So now these are the points that we're going to graph. Alright, so remember our asymptote now is going to come from this, and it's the opposite of in here. So since it's plus 9 in here, our asymptote is negative 9. So we're never going to cross negative 9. And I'm going to kind of tilt the paper here. So it's going to look like this. And it's going to get closer and closer and closer. And cross somewhere in there. So that it looks like this. Right. Our y-intercept is somewhere in here. Alright. We'll talk about that when we get there. Alright, so now our domain, since we shifted this clear over here, and we're never going to cross negative 9, our domain is negative 9 to infinity. Our range is negative infinity to positive infinity. Alright. Now, this is where we're going to change some things. So, as f of x approaches positive infinity, so as our graph goes up, x is going closer and closer to now negative 9. So negative 9 is going here this time. And now as f of x approaches negative infinity, so we're going this direction, it's going towards the positive x's. Alright, so our x-intercept, we don't have a 0 anywhere here in our table, so we can't get it from our table. And you have to kind of extend your graph clear out, but it's going to be about 7. So our x-intercept is 7, 0. And then we said we're never going to cross negative 9, so our asymptote is x equals negative 9. Alright. And the last one, we have a log base 5 of x minus 2 plus 1. So our exponential function is 5 to the x power. So go ahead and make that t-chart. So 5 squared is 25. 5 to the first power is 5. 5 to the 0 power is 1. Then we have the reciprocal, so 1/5 and 1/25. All right, now do the inverse to get log base 5 of x. So just flip everything around. Okay, so we have 1/25, 1/5, 1, 5, and 25. Then -2, -1, 0, 1, and 2. All right, now we have -2 up here. So remember, since it's -2 up there, it shifts all of this column 2 to the right. So we're going to add 2. So we have f of x plus 2. And then plus 1 here means we're going to shift everything up. So we're going to add 1 to this column. So it becomes x plus 1. Right, so 1/25 plus 2 is 2 and 1/25. 1/5 plus 2, we have 2 and 1/5. 1 plus 2 is 3. 5 plus 2 is 7. 25 plus 2 is 27. All right, then we're going to add 1 to all of these. So -2 plus 1 is -1. -1 plus 1 is 0. 0 plus 1 is 1. 1 plus 1 is 2. 2 plus 1 is 3. All right, so we're going to graph those. So you kind of have to guess where 2 and 1/25 is at. Basically, just go super close to 2. 2 and 1/5 is 0. 3 and 1. 7 and 2. Then 27 and 3 is clear out here somewhere. All right. So we have x equals x minus 2 here. So it means our asymptote is x equals positive 2. So when you're graphing, keep in mind you're not going to cross 2. So it looks something like this. Alright, so it should look like that. Alright, so now our domain, because we shifted everything over 2, it's 2 to infinity. Our range is -infinity to positive infinity. So as we're approaching positive infinity in our graph, so as our graph goes this way, we're moving further to the right. So that means we're going positive infinity on the x's, and as f of x or our graph approaches -infinity, we're getting closer and closer to 2. Now our x-intercept is hard to get from our graph, but it is in our table. So our x-intercept is this point. So 2 and 1/5, 0. And we know that we're never going to cross the line x equals 2, so that is our asymptote. All right, that's it for today.